Imagine a family where a child can learn tricks from both parents. In programming a class, the child can inherit features like methods and data from more than one parent class. This is called multiple inheritance, and when the parents themselves also have parents, we get a hierarchical tree of classes. The main reason we use this is to reuse code, avoid writing the same thing over and over, and to model real-world things that naturally belong to several categories. For example, a flying car is both a car and an airplane. It helps keep programs tidy and makes new objects easier to create. Different programming languages let you write multiple or hierarchical inheritance in different ways. In C++, you list several base classes after a colon. For example, class flying car, public car, public airplane, open curly brace, close curly brace. Python uses parentheses, class flying car, open parenthesis car, airplane, close parenthesis, colon. Java does not allow a class to inherit from more than one class. It only lets you implement many interfaces. For example, class flying car implements car, airplane. C# is similar to Java for classes, but supports multiple interface inheritance. Some languages like Ruby have a mix-in keyword, include that behaves like adding extra parent traits. So the exact syntax varies, but the idea stays the same. You tell the compiler or interpreter which other classes you want to borrow from. The diamond problem happens when two parent classes share the same grandparent. Picture a diamond shape. Vehicle at the top, car and plane in the middle, both inherit from vehicle, and flying car at the bottom inherits from both car and plane. If vehicle has a method move, the bottom class might get two copies of that method, one through car and one through plane. Which one should it use? Languages solve this with a method resolution order, abbreviated MRO. Python, for example, uses the C3 linearization algorithm and creates a list like flying car, plane, vehicle, object, and looks for a method following that order. C++ uses virtual inheritance, class car, virtual public vehicle, so only one shared copy of vehicle exists. The method resolution order guarantees a predictable single place to find each method, preventing confusion. Some design patterns are easier to write when you can inherit from several classes. A mixin pattern is a small class that only adds one piece of behavior, like class logger mixin, that provides a log method. You can add it to many unrelated classes without duplicating code. The decorator pattern can be built with multiple inheritance by wrapping an object with a class that adds extra features while still behaving like the original. Composite structures like a file system, where a folder can contain files, and other folders often use a hierarchy, where both file and folder inherit from a common node class, and folder may also inherit from a container class to get collection abilities. These patterns show how multiple hierarchical inheritance helps combine small reusable pieces into larger, more powerful objects. When a class inherits from many parents, the program needs extra bookkeeping. Most languages use a vtable virtual method table to know which function to call at runtime. Each extra parent can add its own vtable, making the object a little larger in memory. The overhead is usually tiny, a few extra pointers, but can matter in very tight loops or on tiny devices. The lookup time to find a method may be a bit longer because the runtime follows the MRO order, but modern compilers optimize this, so the impact is often negligible. The bigger cost is mental understanding. The inheritance graph can be harder, which may lead to bugs if not managed carefully. Explanation. Python example. Class animal, def eats self. Print animal eats, class swimmer, def swim self. Print swims in water, class flyer, def fly self. Print flies in sky, class duck inheriting from animal, swimmer, and flyer. Pass, d equals duck, d eat, d swim, d fly. C++ example. Class vehicle, public virtual void move, open brace std, count less than quote vehicle moves, quote semicolon, close brace. Class car, virtual public vehicle, public void drive, open brace std, count less than quote car drives, quote semicolon, close brace. Class plane, virtual public vehicle, public void soar, open brace std, count less than quote plane soars, quote semicolon, close brace. Class flying car, public car, public plane, empty braces. Real-world use case GUI toolkits often have a widget-based class, a clickable mixin, and a scrollable mixin. A button class can inherit from widget and clickable to get drawing and click handling without writing the same code for every widget. To keep things clean, write unit tests for each parent class first, then test the child that combines them. Use the super function in Python or explicit base class calls in C++, so you know which parent method runs. Debuggers often let you step into a specific base class method, set breakpoints on the parent's code. When a problem appears, ask, is the bug in the child, one of the parents, or the way they interact? Keep inheritance diagrams up to date. A simple drawing helps spot accidental cycles. Refactor large hierarchies into smaller, well-named mixins to reduce complexity, and document the MRO order in comments. If multiple inheritance feels too tangled, you can reach for alternatives. Interfaces Java C#. Let a class promise to provide certain methods without sharing implementation. Think of a contract. Mixins are tiny classes that only add one behavior, and they are often used with composition instead of inheritance. Composition means your class holds instances of other classes. Has a rather than being them is a. For the duck example, you could have a duck object that contains a swimmer and a flyer object and forwards calls to them. Composition avoids the diamond problem and makes the object graph flatter, but you lose the syntactic shortcut of direct method calls. Choose the style that gives you the simplest mental model for the problem you are solving.